Conductometry. Hello everyone, now we are going to talk about conductometry. Conductometry is the measurement of electrical conductivity of a solution. This method mainly depends on Ohm's theory. It is the movement of ions in the electrolyte without occurrence of redox reaction in the electrode surface. The current flow through the conductor is called conductance. Conductance is measured by Siemens, which is the reciprocal of Ohm's -1. Now we will search about factors affecting conductometry. It is the charge and the rate of migration. Increasing the charge will increase the conductance. Migration is related to 6 things. Increasing the size will decrease the conductance, and increasing the viscosity will decrease the conductance. Increasing the temperature will increase the conductance, and magnitude of applied electrical field will increase the conductance. Dielectric constant will increase the conductance. Attraction force between ions will decrease and conductance will increase. Application of conductometry, the purity of water. Distilled water is almost pure and has a very low conductance, but tap water containing ions and so conductance is high. Now we are going to talk about conductometric titration and their curves. Let's see titration of strong acid and strong base. At the first, before we start the titration, the flask only containing hydrochloric acid, which is strong acid highly ionized, and so the conductance is high due to highly ionization of hydrochloric acid to chloride ion and hydrogen ion, which is small in size. When we started the titration, addition of sodium hydroxide, which is a strong base, which is highly ionized to sodium ion and hydroxide ion. Hydrogen ion combined with hydroxide ion and form water molecule, and this decreases the conductance. And as you see in this titration curve, conductance decrease due to combination of hydrogen ion with hydroxide ion and formation of water molecule, and this lead to decrease of the conductance. We reach to the equivalence point when all hydrogen ion combined with hydroxide ion and formation of water molecule. This is mean the equivalence point. Addition of excess of sodium hydroxide to this solution increase the ionization and so increase the conductance. As you see in this titration curve, the conductance increase again due to highly ionization of sodium hydroxide with the additive. Titration of a strong acid and weak base. As the first, before we started titration, the flask only containing hydrochloric acid, which is a strong acid and highly ionized. This is titration curve of a strong acid and weak base. As the first, before we started titration, the conductance is high due to presence of hydrochloric acid in solution, which is a strong acid and highly ionized to chloride ion and hydrogen ion, which is small in size, and this increases the conductance. What will happen when we started titration, and what will happen in addition of weak base to the solution? When we started titration, this will lead to increased hydroxide ion in solution, and so hydrogen ion, which coming from ionization of hydrochloric acid, react with hydroxide ion, which coming from weak base, and form water molecule. When all hydrogen ion react with all hydroxide ion in solution, this is called equivalence point. In this titration curve, we will note that the conductance decreased. Conductance decreased due to formation of water molecule. After equivalence point, in addition of excess of weak base, excess of weak base will lead to no change in the titration curve. This will not increase the conductance, and the equivalence point became part of the curve. At this curve, we will note that At the first, before we started titration, the conductance is high due to presence of hydrochloric acid. After that, formation of water molecule lead to increase the conductance. Increase the conductance? No. Formation of water molecule lead to decrease the conductance. And after that, addition of excess of a weak base lead to no increase the conductance. And so the equivalence point became part of the titration curve. Titration of weak acid against weak base. At the first, before we started titration, the flask only containing acetic acid, which is weakly ionized, which is weak acid, and so number of hydrogen ion is low, and so the conductance is low. This is titration curve of weak acid and weak base. The conductance at the first is low due to presence of acetic acid in the flask, which is weak acid and weakly ionized. What will happen when we started titration, and what will happen of addition of a weak base to the solution? In addition of a weak base to the solution, conductance will decrease more, and this decrease due to common ion effect, which is acting as a buffer. In addition of much volume of weak base, this will lead to increase the ionization, and so increase the conductance. And after that, we will reach to the equivalence point, and equivalence point became part of the curve. This decrease due to addition of weak base to weak acid. In addition of more than volume of weak base to the solution, this will lead to increase in the conductance. The conductance increased due to addition of much volume of weak base to the solution, and so after that, when we reach to the equivalence point, it became of the part of the curve.